Welcome, dear students, to the first video section dealing with calculus, and of course, we are beginning with the limits. That's a stepping stone into the wonderful portion of studying in mathematics called calculus. And first of all, let us look at why limits are necessary, or what is the need for limits. For that, let us look at certain cases or certain simple cases to drive home the point. Now, we know that the square function is given by f of x is equal to x squared, and of course a straightforward and a simple function. And sorry that my y-axis is coming up a little clumsy. Uh, so we know that the square function is represented by a parabola, and of course the parabola is a straight line. There are no multiple lines, and but I think this graph would be enough for the explanation here. And of course here x is defined as x an element of set of real numbers, and that's the case as far as the square function is concerned. Now suppose uh, the result is 0 if x if x is equal to 2. Now this is a very interesting situation. That is if this is 2 and we'd be having a break at this particular point, and so in such a case, how will you define the function? How will you deal with such a situation? Can we go forward by omitting 2? Now that's not possible. So in such cases, we'll have to introduce the concept of limits to further define and characterize characterize the particular function. That's a case where limits are needed. Now let us look at another simple case of a function like f of x is equal to x squared minus 9 by x plus 3, and x squared minus 9, and 9 is the square of 3, so of course it's a squared minus b, so b squared, so you can write it as x plus 3 into x minus 3 by x plus 3, both of them both of them cancel out, and so you are getting x minus 3, and of course quite a simple function, and that is very nice. And so but wait a minute, what if we introduce minus 3 here? That is what if x is minus 3? Now you'll be getting a quite a tough situation, because you'll be getting x squared minus 9 by 0, and this is a tough situation because division by 0 is undefined. So you can see that in this particular case, all values, all real numbers can be brought in for the variable x except minus 3, and so in such a case we'll have to define, for further defining the function, you'll have to deal with limits. That is a particular limit at which the function is not working, or the function needs further explanation. Now let us look at a practical application. That is, and you have a graph which represents the motion of a projectile, that is a moving body through the atmosphere. And suppose the projectile is a rocket, and the interesting point is that after a rocket reaches, so this is a graph for it, and after it at a particular point, say at it's a time and it's height, at a height of around maybe 3,000 meters or 3 kilometers. and at around maybe 3.3 minutes or something like that, the rocket is breaks apart. So whatever the case, it's not a successful launch. Now we are not looking at what are the causes for the failure of the rocket, but we are looking at the functional aspect. So at this particular point, if we are to flow, if we have to plot the graph would be having multiple branches coming out of that single line. So anyway, I don't think anyone would have seen or worked with such graphs. But whatever the case, it's for the case of explanation which we are dealing with. I'm bringing it here. So if this is a function which deals with the flight of the rocket with respect to the time it takes, then you can easily say that the function f1 would not be enough to explain the entire flight of the rocket, because we have to deal with the another function f2 or multiples of f2 to deal with that, which simply means that the time factor would bring about a limiting factor to the function. So once again we are looking at the limits, and which simply means that if time is the input variable in this particular case at 3.3 minutes, so you can see that the whole function cannot be defined on the basis of what was done till that point, because the rocket is breaking up. So as I say, case where we see that the time that's the input value, that is x, is coming up as a limiting factor. So all these cases prove that the concept of limits is necessary to further define functions. In the sense that the concept of limits is necessary to further define functions where there are discrepancies in functions. That is where some I mean the range of the function is not uniform, or in cases where in domain, or we are dealing with a particular piecewise or fractional functions. So in such cases, to further define the functions, you'll have to deal with limits. That's the introduction to why limits are necessary, and in the next video we'll be looking at what limits are. Thank you.